Here I am teaching you about economics. Economic applications of area between two curves. Who'd have thunk it? It should be fun. I had fun reading about this stuff. So we want to talk about supply and demand. That's basically there's two main applications in this section. And the first one is talking about supply and demand, right? And so what we're going to have is we're going to have a demand curve and a supply curve. The demand curve, we're going to denote D of X. Now, you guys that took classes where you did this in other business classes, is that what they do? They use little d for demand? Or do they not even talk about variables? You did? Did they draw curves? They drew pictures?
Yeah.
So they draw pictures. What's that?
Just slopes.
Slopes.
They like to teach you like demand is down sloping and then supply is like.
Well, yeah, that's actually going to be important. The fact that demand here is, so demand, this is what I call a decreasing function. Yeah, that's going to be an important point for us, actually. It was actually in Calc 1. It was even more important. And supply, we're going to use S of X in our book. Okay? Now, let me explain what these things are. X is the number of items produced. That's your input. How many items are produced? Do you know what the output is for these functions? The price. So the output, S of X and D of X, are prices. And I think this is weird. A little strange. So I wanted to make a point of it. Because when I first read this, I said, wow, this is kind of weird. See, here's the thing. What do you control as a business owner? Okay, now, yeah, I guess there's two answers there. Someone said price and someone said supply, right? Well, do you control price? Let me ask that. You say no? So in order to make more sense of this, I want to stick with an example. Okay? I'm going to give us a supply curve and give us a demand curve. And then we'll have something to talk about, and then I think maybe that'll help. And we'll just play around with it. So here's a nice example. Okay? I don't even have a product. I don't have a story. I just have a nice supply curve and a nice demand curve. Notice that as X increases, as the number of items produced increases, the price, the demand, goes down. What's demand? Demand is the price the consumer will pay for the item. Right? Now, if there are more and more produced, the consumer's not going to pay as much. Doesn't have to. The market says he doesn't have to. But does that make sense? And you guys got to correct me if I'm saying something totally wrong. Okay? Because like I said, I'm out of my field. Supply is also a price, right? This is D of X. Supply is also a price. What price is it? Price at which what? The producer of the item will what? Will sell. See, I have a house that I own. But if any of you wants to give me $500,000 for the house, it's yours. Okay? So, one house, right? Okay? Now, does it make sense that that's an increasing function? Let's think about that. No, something's wrong here. Let's correct this. The price at which the producers will supply X items. That's the deal. Okay? I have at home, a collection of DVDs. And if you say, I'll give you $1 for any of your DVDs, I'll say, okay, I'll give you these couple that I don't need anymore. But if you say to me, I'll give you $100 for each of your DVDs, I'll come up with a lot more DVDs I can part with. Does that make sense? As the price goes up for an item, the suppliers are going to provide more. So, again, it's still kind of backwards. But if I say, look, there's X items, right, that has to match up with a price. So what happens is, you want to know what's going to happen in the market. And of course, we all know that these two curves, supply and demand, have to equal each other, right? That's what the market says is going to happen. I'm sure you've learned that in social studies, even when you were young, right? So what happens is you find the intersection of the two curves. Now, how did I find the intersection of these two curves? Well, I graphed them, and I looked at it, and I found the closest integer point. All right? I didn't do the algebra. I mean, what would the algebra be? 20e to the negative 0.01x equals 0.005x squared. How do you solve that? Good luck. Okay? And I teach this stuff for a living, right? You tell them to use a calculator. Okay, that's what you do. I don't know of a nicer way to solve for x in this situation, and I'm not going to pretend to. So here we go. What's this mean? This says x equals 49, and what's that? That's the price. So this says, whatever item it is, the market dictates that the price is going to be $12. And what else does the market dictate? 49 units are going to be produced. Okay? Oh. What will the revenue be? That's pretty easy. What will the revenue be? 49 times 12, right? So let's see, 50 times 12 would be 600. So subtract a 12. So what's that, 588? So the revenue, the market dictates in this particular picture that the revenue is going to be $588. Okay. So we have supply, demand, and revenue. Now, let's clear the screen for a minute. And let's draw a picture of the revenue. How do we get the revenue again? What do we do? What's that? R1 equals C1. Well, that was in the last thing, yeah. But I don't know R prime or C prime here. All I know is D of x and S of x And then what? Oh, I'm asking how do we get revenue? I just said this on the last slide, but maybe I glossed over it. Do you guys understand why the revenue is $588? Why? Price times quantity, right? Okay, so let's go back to the new slide. And see, when you do price times quantity, I claim you're finding the area of a rectangle. This one. Well, 49 should go right there. What's the price? $12? Right? That's the price. That's the quantity. And by the way, your book is going to call this value right here DMP. The price, the demand, the market price. They call it DMP. But this, okay, in our example is 12. And if I compute, here it is now, area of that rectangle, that's the revenue. Okay. So area of this rectangle, right, is 588. Sure, it's going to be 12 times 49. That's what length times width is, right? So maybe you're asking, why am I showing you the picture? Okay. I guess what happens is that for the other economic terms in this section that we're going to introduce, it's not so easy to figure out what they are. But it's easy to show you on the picture what it is, and that's what I want to do. Okay? So the area of this rectangle is the revenue. Okay. So the next thing I want to talk about is something you may have studied before. I want to see a show of hands of people that have heard of this. Consumer surplus. Let me see a show of hands. What? You hated calculating that? How'd you guys calculate it? It's kind of like a triangle. It's true.
That includes like the dead weight loss you're looking at. You're also looking at it might be marginal cost, and that forms triangles in the left part.
Wow.
The top triangle might be I think the top triangle is the producer surplus, and if you calculate the bottom one, that's actually the consumer.
So when you say triangle, do you guys see any triangles up here?
Not exactly straight lines.
Right. And maybe when you guys did this in the classroom,
Yeah,
they were straight lines. But life's not like that. You know, yeah, so what am I doing here? I want to find the consumer surplus. What that means is this green area up here.
Oh, in the bottom of the...
Right, okay, and so there's going to be something called producer's surplus. And that's this area down here. Okay? So this is a real nice application. It's good to have calculus in your belt so you could talk about something besides a straight line. They had to be straight lines because you knew how to do a triangle, but that's all you could do. So I'm going to find, let's do consumer surplus first. We'll do the green one. How do I find the consumer surplus? Well, I find the area of this green space. Okay? So what's that mean? Well, we're going to integrate. From what to what? Hey, you guys got to be careful here. There is a 12. I see the 12. The 12 is this, right? You know, they wrote DMP equals 12. Maybe I should just call that line Y equals 12, right? That's the equation of that line. Yeah.
Technically, you could Pythagorean theorem.
If this were a straight line, I could.
Which line? The bottom one?
No, the bottom one is a straight line. I'm with you on that, because it's just Y equals 12. What's the equation of the top curve, though? See? It's this d of x is this stuff. Now, I bet in your econ book they made it a straight line. Right? But it's not. So how am I going to do it? I'm going to integrate top minus bottom. Right? That's what I'm going to do. So what are we going to do? We're going to integrate from something to something, I don't know what. What's the top going to be? 20e, I guess I covered it up pretty good, to the negative 0.01x, right? That's the top curve. And now what do I subtract? Well, just 12 dx. That's going to work out nice. Integrate from what to what? 0. Why 0? Well, I guess it's this, right? There's the a, x equals 0. And how far do I want to integrate out? Yeah, 49, because that's the upper limit. So we're going to go from 0 to 49. So in general, what you're going to do is you're going to go from 0 to, well, I guess the right x value. The x value where supply equals demand. That's what you do in general. All right, but let's work this out. So we're going to integrate. So I integrate this first guy, and I get 20, and I get this back, e to the negative 0.01x, but what do I have to do? Divide by negative 0.01, okay? So that works out nice. And then subtract 12x, and we'll take these values, and we'll go from 0 to 49. And by the way, 20 divided by 0.01, that's like 20 times, that's negative 2,000. So I have negative 2,000 e, bless you, to the negative 0.49, when I put a 49 in there, minus 12 times 49. And then I have to subtract what happens when I put in a 0. So I'm going to be adding 2,000. Because that's what happens. And then subtract 0. So that's what happens when you put in the 49, you put in the 0. Okay, so there's my 588. That's interesting. I don't know what this is, so I need a calculator. Turn it on. Y equals. Clear it out. Oh, I guess I don't need that. I just needed this. So I have to do negative 2,000 times e to the 0.49 minus 12 times 49. That's my 588. What's positive 40? 0.49 is positive?
It's negative, right?
Oh, I need a negative, yeah. Sorry, thank you. So I need to insert a negative there. Otherwise, we'll be totally off. Okay, times 49. And then we're going to do plus 2,000, right? And that ought to do it. So I got a consumer surplus of 186, what are the units? Dollars. So what's that mean? So again, the whole key to these problems, when you want to do these, is, where did I put it? Top minus bottom. Okay? So for the producer's surplus, we're trying to figure out this blue area, right? So what's the top curve here? So for producers, surplus. We integrate from 0 to 49. What's the curve on top of the blue region? Well, that's this thing, 12, right? So it would be 12 y equals 12, minus, now what's the bottom curve? I guess I scratched it out pretty good. 0.005x squared, okay? You could integrate this dx, and it'll give you a value. You guys follow that? This is the money. So how do I want to say this? This is the money that was lost thanks to the market. Right? Let's see if I said that. So the actual revenue is this red area. The producers were willing to make 10 items if they were going to sell for $1 each. But once the price went up to $5, the producers were willing to make 30 items. And once the price went up to $12, more people got involved and the producers were willing to make 49 items. You guys follow that? So Joe Schmo over here that was willing to make it even to sell for $1, he was going to make 10 of them. When other people started making them and the price went up, when the price went up, he made out big time. So the price went up to 12. How much did he save? He made an extra, a surplus of, boy, a lot of money, right? All that area in there. That's called producer surplus. It's the money that was made extra because of the market again. We'll do these problems from page 546. I'll walk you through what's happening here. Okay, so 61 says, in 1988, okay, L of x equals 1.93 x to the fourth minus 2.96 x cubed plus 2.12x squared minus 0.09x. What the heck are they talking about? All right. So what I mentioned was you talk about percentages, okay? So I'm going to put the number 1 over here. And I'm going to divide it up into 0.2, 0.4, 0.6, 0.8, and 1. And what I could do is I could figure out how much of the wealth does a certain percentage have. Okay? Now, I'm going to draw what would be, I guess, a society where everybody had completely the same amount of wealth. What would that look like? Okay, communism? Yeah. Maybe the ideal of communism, what they wanted to do, in theory. Yeah, a straight line. Because what happens is that if you pick 20% of the people, and if they all own the same amount as everyone else, how much of the wealth have you just accounted for? Well, 20% of the wealth. So I could put a point right there. This red line is going to be the ideal, I don't know if I want to say that, but the perfectly fair line, let's say. Everybody has the same amount. Equal distribution of wealth. 0.4, 0.4. 0.6, 0.6. 0.8, 0.8. And I guess the last point here would be 1, 1. If you have 100% of the people, you have 100% of the wealth. And by the way, it has to be true that any curve I draw for any country has to go through 1, 1. If you're talking about 100% of the people, you're talking about 100% of their wealth. And if you talk about none of the people, you're talking about none of their wealth, right? And so we're always going to go through those 2 points, 1, 1, and 0, 0. So I'm going to go ahead and draw this curve, although I don't really know what it looks like. Now, how did they get this curve? I'll tell you what they did. They didn't have a curve, but they had some data. They had 5 data points, like here, 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 and there, right? Or something like that. They knew that 20% of the people own 10% of the wealth. 40% of the people own 20% of the wealth. 60% of the people owned 40% of the wealth, or whatever the numbers were for 1988. You guys follow that? And then they did a best fit curve using their calculator and got a curve that goes right through, well, might not go through any of the points except for 0, 0, 1, 1, but it approximately goes through them. You guys follow that? Okay. So now we want to do what's called the Gini Index. So the Gini Index, well, okay, there's a few different ways to define it. But one way to say it is, it's 2 times the area in between. That's the Gini Index. And that number is going to tell us something about 1988, and then we'll compare it to something about the other year and go from there. You guys follow that? So let's see what happens. What do we do? Well, we're going to do 2 times integral from what to what? 0 to 1. What is it that we want to integrate? Top minus bottom. So what's the top line? It's that red curve. What's the equation of the red curve? Yeah, this is the line y equals x, right? Because they're the same. Okay, so what we're going to do is we're going to integrate x minus L of x. And that's going to give me the stuff in between, then I multiply by 2, and that's called the Gini Index. Okay. There's other ways of thinking about the Gini Index, but they all have to do with this picture, and they're all equivalent to this. We could show that. Oh, quick show of hands, people that have heard of the Gini Index before? Nobody. Okay. So here we go. We're going to integrate this dx. All right, so we have 2 times integral from 0 to 1. So I guess I need x. Oh, wait, we're going to subtract 0.09x. So let me write it this way. Let me write it as 0.91x, okay? 0.91x plus 2.12x squared minus, oh no, I screwed up. Do you see where I screwed up? We're subtracting it. So minus 2.12x squared plus 2.96x cubed minus 1.93x to the 4th. Yeah, I'm going backwards. For some reason, I thought that'd be easier because I wanted to combine the x with the 0.09x.
Wouldn't it just be, why is it 0.091x?
Because I had 1x, 1 minus, oh, it'd be plus. You're right. That's not right. What is it going to be? 1.09. Thank you. Because when you subtract the 0.09, the negative 0.09, it becomes adding. Okay. So this is 2 times, and now we integrate all this stuff. So I get 1.09 over 2x squared. Is that okay? Minus 2.12 over 3x cubed plus 2.96 over 4x to the fourth minus 1.93 over 5x to the fifth. And one of the beautiful things about these problems is that you're going from 0 to 1. See that? What's going to happen when you integrate from 0 to 1? Well, you put in the 1s, all the number parts stay, but the x's kind of go away. See that? And you put in the zeros, and everything goes away. So actually, I could just take out the calculator now and get my final answer. So I'll do that, which is good because we want to leave after this. So let's see. Okay, so we'll go to the, well, we'll just quit and clear it out here. And let's do, okay, so 2 times, open parentheses, 1.09 divided by 2 plus 2.12 divided by 3 plus 2.96 divided by 4. Oh, we did something wrong. Is there a minus up here? Good catch. And then minus 1.93 divided by 5. And so I got 0.384 for my Gini index. So when we come back next week, we'll take a look at the other years that you guys looked at, and then we'll talk about what it means.